Hello and welcome. My name is JP Metcalf, and I have a folder filled with stereo pairs from Worldview 3. And the natural thing to do with stereo is to convert them into a digital elevation model through some sort of process. And I'm going to do that in ENVI. So let's get ENVI open. And the first thing I want to do is look at the imagery real quick. And Worldview 3 ordered these apparently TIFF in tile files. So if you open up the tile files, that'll bring in the associated RPC location information. I'm going to zoom all the way out. I just want to check out what they look like in stereo. Okay, I can see the mountains moving. And then it looks like they're from the same day. If we look at the metadata, Worldview 3, Stereo 1B product, if I come down to time, it says that these were collected 2017, September 3rd at 1856 Zulu. And then the next one down is 1855 Zulu. So the second one is actually collected a minute before. So this was collected in the same pass where the satellite collected an image, and then as it passed a little bit forward, it went back and collected the same area, giving us a stereo pair, which is ideal in the same pass. So we don't have any change really to speak of. So the next thing I want to do is I'm going to go into my toolbox and open up the terrain toolbox and look for DEM Extraction. Open that up. And we have a few different tasks in here, but I'm looking for this DEM Extraction wizard for new, meaning that it's a new project. So the first thing we need to do is select the stereo images. So we can only select left and right, not multi-stereo. So I'm just gonna select the first one up here is the left, and the second layer down is the right. And then because of the RPC information, the scene elevation of meters will all automatically be calculated. Then from here I can hit next. And now it's looking for stereo ground control points. I don't have any ground control points for this set of imagery, but what I can do is just kind of move past this and assume that it's a relative DEM result. Maybe I can fix it later, or maybe I can go and find some GCPs. But for now, I'm just gonna move past this and then get into the tie points. So in this part of the wizard, we can generate tie points automatically, which by default will try and search for 25 different tie points. And then we can set parameters for the search window size, the moving window size, and this is all gonna matter about the resolution of the imagery. If we bring up the help file here, get a little bit more information about tie points. The relationship between stereo images by selecting or generating tie points, that's the definition. The tie points are used to define epipolar geometry and create epipolar images, which are used to make the DEM. We got a few different options. We can generate them automatically, define tie points interactively, which we'll be doing, or just read tie points from a file that maybe you've spent some time generating these tie points already. And if we did it automatically, here's some information of what you might want to think about if you have different resolution in what your image is set to be. Okay, so I'm just gonna say define tie points interactively, because I know if I do it automatically, there's so much relief in this image. A lot of the tie points are going to be pretty poor in the correlation. So as soon as you hit interactive, a little 3-window setup comes up for each image. And then what I like to do is make the scroll window a little bit larger for each image. And then make the main window a little bit longer. And then I'm gonna pull my little wizard out of the way. I'd still wanna see that though. So what's gonna happen is I'm gonna search around in this image and find pixels that are the same and try to keep them on the ground, not too many like in the mountains. So I would start off here, let's see. Make my zoom window a little bit bigger as well. I'd find something in a corner. So between the two images, I can see that these little lakes are common. So I can move down here. And I'm just gonna expand my search results from around this lake just because I can see it pretty easily in that scroll window. And I found something, let's see if I can use it, right here. And I'm just gonna make sure in the zoom window that the crosshair is on the pixel that I want. And then in my wizard, I'm gonna say add. And now it says the left X, left Y, that's the location in pixels, compared to the right X and right Y. So I'm storing that. I have a tie point 1 of 1. We have to get up to 9 before it actually generates the Y parallax error. We want to get that less than 10. So the next thing I want to do is get the 4 corners. Now I'm going to look for features in that scroll window that are similar. Might be kind of hard to find in this area. Here we go. We are over. Let me just get my bearings here. There we go. Does that look like the same thing? It looks a little different, right? It can be cumbersome to search for these on your own. That's why we have an automatic process. So let's try this. And I don't think I'm seeing the exact same thing here. I might try another area. Or what I can do is skip this for now and make sure I get 9, and then I can start to predict the location. Here we go. Looks like a little bit of ice. And pick the inside of this little inlet. Say add. I'm gonna go up to this corner, a little bit darker. Move around for something that I can find. There we go, looks like a little outlet. Now with water, you might be a little reluctant to use these as tie points. I mean, this was taken a minute apart. I don't feel too bad about this. I'm gonna assume that I have the same point on the earth here. I'm gonna pick one in the middle. I can see something bright by this little lake here. I'm moving around with my arrow keys. It's a lot easier in an urban setting. See this little bright area? And I'm going to try and find that. Going a little bit too far. There we go. Whatever this is, I just know it's bright. It's probably the same thing. And due to the change in viewing angle, the area just looks a little bit different. Let me make sure that I'm actually looking at the same thing. I think so. If not, it'll tell me that the air is really high, and I can always just go back and fix that. Let's find one in the north part of the image. Whatever this is. I'm looking for that feature. Maybe I'm too far over. I should be pretty close, but maybe let's just try a different area real quick. I'm looking at this little part of the lake. Here we go. Right here, here. Looks to be like a bright rock. Add that. We just want to make sure that these images are well tied together because we're going to compute that parallax to produce the stereo. Let's see, here's another one. Let's kind of search around for a second. Okay. We use this little area. Add. You can already get a sense of how long a tie point project will take. I can see another little image area to search for points. It's a little hard to do in areas that don't really have a lot of texture. Normally, if you're doing a photogrammetric campaign with, say, aerial, you might put down these big black and white targets. You can go out and GPS those and then definitely have the ground control. I started out over here. Now I'm curious, see if I can find it again. Here we go. That looks like the same area. I can see those little bright spots. I'll find something here. If anything, there is a set of rocks here. something bright. It looks like a lot of the trees are laid down, but this one looks exactly the same as this area. So I'm just using the zoom window to actually pick the same pixel, say add. Remember, I got to get up to 9. So maybe start looking in this area here. That's going to be a little hard. How about here and here? It's like a little river. I'm just looking for some kind of, maybe a bright spot. But I do want to get something towards the edges. And if you get too close to the edge, you may lose your image overlap. So let's get a few more just to get those 9 in, and then we can just put down a point and then predict it in the other image. Okay, here's some rocks. That looks like it's similar, especially this pixel right here. Add. The contrast is not great in this area. How about here? So I know that this area is the same as this area. That one is easy. Add. All right, so now the minimum Y parallax is almost 6, which is good. We're less than 10. So because we have those 9, if I look over in, say, here, and just settle on a point that should be easy to see in the other image. Let's say here. Then I should be able to predict the left. And it may not be perfect, but it'll get me in the area. So I'm looking for the same kind of pattern. And there it is. I'm gonna pick that little corner here. Say add. Parallax got a little bit worse, but we're still less than 10. If you have a larger screen, you can spread out these dual windows here. There's a little down tree. I'm not concerned so much because I know a tree has a little bit of elevation to it. And usually, depending on how the images are oriented, you can usually just go up and down. I think I'm way off now. Probably more over towards here. There it is. Add. Now my parallax came down a little bit. We want to find some up in this area. I'm honing in on this little white spot here. Predict left. It looks like I'm close, but not that close. There we go. I can even use that bright pixel right next to it. Say add. We're recommended to have 25 tie points, so we'll add a few more. I might not go all the way to 25. Ooh, this is a good area. Predict right. There we go. We're in the area. Use this. Pick a little corner. Add. Okay, where are we missing a few points? Maybe out towards this edge. Got this little bright thing here. It's a lot darker than this image. That looks like it's it. Sometimes the hard part is so much relief. You see different shadows, you see different angles. Add. And it looks like I'm getting the right pixels because my Y parallax isn't changing too much. Is there anything good in here? Oh, actually, I was pretty close the first time. There we go. Oh, that's interesting. You can see a little broken up ice melt. Use the very corner of this ice to add. Still staying under 10 for the parallax error, or maximum Y parallax. I did want to find one out here. I'm just looking for that shadow area. There we go. And it looks like this rock is the same as this. Okay. Try to match up this image. So it might be a little bit harder. But I think I'm in the general vicinity. Let's follow this down to where it bends. Okay. Little bright spot there. We can do 25. It's if you want, you can pause the video, work on these on your own. You can see some infrastructure. Oh no, it's just down trees. I think this would be easy to find in this image though. It's gonna follow the water. It looks like we're next to another tie point. Find something in here. That turns out to be a cross. That's pretty good. Okay. That looks to be the same as this. Still under 10 for Y parallax maximum. Add a few more. Let's get up to 25. We looked out in this area. A lot of trees. Okay, there we go. Now the prediction is getting a lot better. I don't feel too good about that one, but at least it's something. The Y parallax actually came down a little bit. Are we missing any areas? So this is right above that little lake feature. Now, if I can find that area, it's got to follow these rocks. Oh, okay, okay. That looks incredibly similar. There's a little bright spot here. And now we are at 24 points. Am I close? Not really. Got to do a little bit of searching around. Although this looks good. Although I'm near another tie point now. But if I can find it quickly, then I can use that. There it is. Okay. This rock is the same as that rock. I'm a little hesitant to use tie points in the areas of relief, but we'll see. So we have 25. What I want to do now is make sure I save these points. I'll call these manual tie points. And say OK to save. And then I can show the table, and it'll tell me which tie point has the highest rank in air. So if when I go to extract the DEM and I find out it's really messed up, I can always come back to this step and refine my tie points. But for now, we're under 10. So I'll hit next. And we're going to generate the left epipolar image and the right epipolar image. And then to examine the results, we can set some kind of combination as red, green, or blue. For the output names, I'm going to come back here. I'm going to make a new folder. We'll say epipolar. And I'll just use the default name that it gives it. And say next. Now it's going to ask, okay, what kind of coordinate system? We'll just use the one of the images that came in. Looks like it's UTM zone 12 north. Okay, so here is where we should probably look at the help. So step 8 of the DEM Extraction wizard allows you to specify the parameters for the extraction, thresholds, size of the area to perform image matching. 2 sections, DEM extraction parameters and DEM result. If you set the minimum correlation between 0 and 1, this is the correlation coefficient threshold used to determine whether or not 2 points are a good match. Okay, so we have tie points, but now we have to figure out the automatic tie point generation that's going to happen in the background, because you need to extract it for the whole image. That's how you get the elevation at each pixel. So between 0 and 1, we've got some edge trimming, kind of explains what that is, moving window size. Let's see what we have real quick, because there's some values by default. It says the minimum correlation is 70%. Background value, that's just in the DEM at the end, is for areas that have no data, we'll say -999. The moving window size is 5 by 5. Terrain relief, I know, is high. And then there's a terrain detail, which is set to level 5. Let's check out what level 5 means. To determine the level of terrain detail, DEM Extraction uses image matching to find matching features on the left and right image of the stereo pair. The use of terrain detail determines how precisely you wish to represent the terrain in the DEM output. The levels range between 1, which is minimum, and N, which is maximum. The level 1 terrain detail indicates that image matching stops after the coarsest level of image matching is finished. Level N indicates that image matching is performed on the highest image resolution possible. Okay, so basically if you set it to level 1, you're going to have very coarse resolution DEM. You set it very high, you're going to have it, it's not going to be at the resolution of the original image, but it'll be a little bit worse. Terrain detail is a major controlling factor that determines the processing time needed. Okay. So let's say, these are sub-meter images, panchromatic, and we want maybe a 5-meter DEM that we can, maybe we leave it as a default. I set the type of terrain to high. If you set that option, the terrain consists primarily of mountainous and high terrain relief. Topographic features with large relief displacement are not smoothed. Okay. What about the moving window size? It defines the area in which to compute the correlation coefficients between the 2 image templates. A larger moving window size yields more reliable yet less precise matching results, more processing time. So the default is 5x5. So let's try what we have now. And so the output data type is integer. That means we're only going to have meter level increments. I kind of want sub-meter level increments. And then we output the DEM. I'll just make a new folder called DEM. Then I'll just call this worldview 3. Hit next. And we're done. The next part of the extraction wizard at least. So we can load the DEM results to display. I never liked that 3 window thing, so I think what we can do is go to finish. And then we can save the current state of this wizard to use this at a later time. So I could say yes. And then in here, I might say in DEM Extraction, I'll just say wizard dot text. And then if I open my data manager, I should have the elevation data set. Okay. And then, let's see, we're at 40 centimeter resolution for the DEM. And then I can change a color table. So it's really low here down in this valley. Let's see. We have, what is that, the right epipolar image? And then this is the left. So if I just turn these original images off, anything that moves has a more exaggerated elevation. That's pretty cool. And it looks like they are the same size. Let's see if I can get this to function. Oh, interesting. Zero. Huh. I don't think that's working the way I think it's going to work. There you have it. That's DEM extraction. Real quick before we get out of here, I ran this process through another task that's up in geometric correction, and that's called RPC orthorectification using DSM from dense image matching. So the ortho photo, which has all the lean taken out of it, I should be able to get in here so we could just at least see what the result looks like compared to the original epipolar images. So I have the ortho up top here, so I shouldn't really see that exaggerated lean. With the mountains. But if I compare this, hold on, looks like it's reprojected. Now you can really see the elevation change. And if I move these down to the bottom here, and then I turned on flicker, there we go. That's how much changes with orthorectification. And as a matter of fact, I also produced, I should have a DSM from that process. Looks a little bit rough, but I think some parameters need to be tuned. Let's look at the elevation compared to this. And there you go. That is DEM Extraction Wizard. Thanks for watching.